Just a piece of paper today and a beverage. Let's talk about absolute value equations. As you can see here, I have an absolute value equation. We're going to solve it. We're going to solve it much like we do a linear equation, but it has some different elements that we need to watch out for. So I have predetermined steps that I want you to identify for every time we do one of these. My first step is called clean it up. Which simply means get rid of everything around the absolute value symbols and just narrow it down to just that on one side of the equation. So we have some extra stuff here. We have the plus 10, we have the times 2. Those things need to go. What I don't want you to do is distribute across the absolute value. We're not going to do that. Okay. So we're just going to get rid of those things first by starting with subtracting 10 from both sides and then just writing down what we have. So we got 2, we got our absolute value, and then now we have 8 over here. Again, do not distribute the 2. We're going to clean it up. We're going to get rid of it. So we're almost down to the absolute value now. So how about we just divide by 2 since we're multiplying. And we have 3x minus 8 within the absolute value symbols, and that's equal to 4. Okay, that is step 1. That is the cleanup phase. Step 2 is to think. Oh, I didn't know we'd do that. Well, yeah, you do, because you want to think about, is this possible? Can you think of a number that you can plug in for x, first of all, that will create a positive value? Okay, so as x becomes larger in value, like 3, 4, 5, you can probably think of a number you can plug in for x right now that would actually balance this equation out. Okay, but the idea with absolute value is that if you think of the function family, it's a v, so it has the possibility of intersecting the x-axis at 2 points, which means it could have 2 possible solutions. So you have to account for both solutions if they exist. So what I want you to do is draw a line right here, and we're going to try to account for both solutions. Okay. So on this side, all I want you to do is take the absolute value symbols and throw them away. Okay, and just solve the equation as if it was a standard linear equation. All right. So plus 8. 3x equals 12, x equals 4. Okay. Now on the other side, this is where it gets a little interesting. What I need you to do is I need you to become the Incredible Hulk, okay? And you take the absolute value symbols and you bend them into parentheses. Like that. Oh, and then don't forget to put a little negative on the outside. Okay. So what you're doing is you're looking at the positive and negative solutions that could exist. Not to say that the answers will one be positive, the other one be negative. That doesn't always hold true. But you're accounting for both possibilities. Okay. So you bend the absolute value and put a negative out front. Okay. And solve. So how do you want to solve this? You could distribute said negative. You could divide the -1, which is right here, to both sides, which is my preferred approach. So 3x minus 8 equals -4, and go from there. Okay, so add 8. 3x equals 4, divide by 3, and x equals 4/3. Okay, so what we have here is 2 solutions, x equals 4 and x equals 4/3. If we were to take the original equation and plug it into Desmos and set it equal to 0 or equal to y, we should intersect the x-axis at exactly these 2 locations. Let's take a look. All right, as you can see, what I've done here is I've taken the equation and I've actually set it equal to 0 by moving the 18 to the other side. So I had to subtract 18 from both sides, which created a -8 when I combined it with the 10, or that was already there. And by doing that and looking at the function now in Desmos, I can see clearly that it has 2 solutions that cross the x-axis. One of those solutions is at 4, and the other one is at 1.3 repeating, which is 4/3, which is what we got. So it works. It appears to be so. Way to not screw it up this time. What do you mean, screwed it up this time? Just be that. Can't write these days. Sorry. Oh my goodness. Oh my goodness. Da 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 da.